We're going to have a look at how to draw linear graphs using a table. Now, whilst this is D grade topic work, the same method can be used from D to B grade questions. And it does lead on to A and A star work. In order to complete this section easily, please make sure you know how to substitute negative numbers. A bit of background. Every coordinate, as we write it, has both an x and a y component. And if we look here, this is the x part of the coordinate and this is the y part. It allows us to plot graphs, but it also helps us to find connections. If we look here, can you see a connection? What you may have seen is that these, the x coordinate, are all 2. And if we plot that graph, we get this, and the equation of that line is conveniently x equals 2. Let's have a look at this. Could you find the equation of these lines? If you're not sure, pick a point on the line and write its coordinate. This one is 4, 5. So on that line, I have a coordinate 4, 5. Let's choose another coordinate, 4 minus 1. And now I can look for my connection. And my connection is x always equals 4. So the equation of that line is x equals 4. Please pause the video, have a go yourself. And you should have found that this was x equals 9. This was x equals minus 3. And this was x equals minus 10. Let's keep. Here, again, what do we notice? Well, this time we have a different coordinate. And I'm sure you noticed that this time y always equals 1. Graph, there we are, and we now know that the line here must be y equals 1. Notice how y equals 1 is parallel to the x-axis, and the x-axis is also y equals 0. It seems very confusing. It's the opposite way to how many of us would expect. But there's our line y equals 1 of y equaling 3, y equaling 5, y equals minus 2, and y equals minus 5. So if you can see a connection, in this case it's somewhat different, between these two coordinates, that might give you the equation of the line. But a typical D grade is different. This is the sort of thing you'd see in a D grade question, and some of the answers might already be filled up in. What it's asking is for you to plot the graph of y equals 2x plus 5. We know this is a linear graph because there is no squared number here, no power there. So looking at this linear graph, we then expect the graph to be a straight line. Okay, so we're looking for a straight line answer, and we're starting off with our first value of x as minus 3. So 2 lots of minus 3. I've put minus 3 in place of x, and I'm plussing 5. There's a hidden plus sign here. Plus and a minus is a minus. 2 3s are 6, plus 5. Okay, I draw my number line. I'm at -6. I go up 5. I know my answer is -1. Keep going. This time 2 lots of -2 plus 5. Well, a hidden plus there. Plus and a minus is a minus. 2 2s are 4. Plus 5. That's -4. Go up 5 places. My answer is +1. 2 lots of -1 plus 5. 2 minus 1s are now -2 plus 5 gives me 3. And slowly I fill in all my answers. 2 zeros is 0 plus 5 is 5. And this is 7, 9, 6 and 5 is 11. We now have both our x and y component. The top of the graph is our x part. Here it says x. And the bottom is our y part. We've already said that every graph has an x or every coordinate, has an x and y component. So here we've got coordinate -3, -1. Here we've got -2 plus 1. Here, -1, 3. And we keep going. 0, 5. You can do the last 3 yourself. So moving forward, with these points, we can then draw our graph. And I'm going to plot these points. So -3, -1. -3, -1. That's my first point. -2, -1, -2, 1. -1, 2, 3. Oops, a daisy. 0, that means I don't move and I just go up 5. And I keep plotting the points. 1, 7, 2, 9, and 3, 11. I keep plotting the points and then I can... So now we've managed to plot our coordinates, we can draw a line straight through them and we can label that line. So we now have completed our table of values. From those table of values we came up with our coordinates and we've plotted those coordinates on our graph. We've drawn a line through the points and we've labelled the line y equals 2x plus 5. A follow-up question, an examiner might ask, check if other points fit on the line. Well, firstly, if they ask to see if 3, 5 fits on the line, you may just go 1, 2, 3, 1, 2, 3, 4, 5 up. That's our point there, and you can see it's not on the line. However, if you haven't had to draw the graph and they're asking if 3, 5 fits on the line, well, you know your x value is 3 and you need to see if your y value would then be 5. So let's try it. Y is 2 lots of x, 2 3s plus 5. 2 3s is 6 plus 5 is 11. That coordinate cannot fit on the line. But a coordinate that would is 3, 11. Let's double check. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, that one is on the line. And actually, I knew it was because there's one there. Good luck, and I hope you progress smoothly through the attached worksheet.